All right, here we have a different type of average atomic mass problem. In this case, we know the masses of the two isotopes. We know we have Z240 and we know we have Z244. But we don't know their breakdown. We don't know what percentage there is of each one. All we do know is that the total average atomic mass is 241.38. So we can get some information from that. If the average is 241.38, that's closer to 240 than it is to 244, so there must be a larger percentage of 240. The goal now is to figure out what that percentage is. So what we can do whenever we have an unknown, we can establish variables for them. So the amount of Z240 there is, we can say there is X. And rather than use percentages, it's usually easier to think of these as decimals. So like 50% would be 0.5, for example. So what is the decimal amount of 240? It's X. Then we say, what is the decimal amount of 244? Now, we could call it Y, because we don't know that either, but we want to try to establish a relationship between these two decimal values. And the idea is we know that percentages always add up to 100. Well, likewise, decimals always add up to 1. So that means the decimal amount of this would be 1 minus X, because 1 minus X plus X gives us 1. If the decimal amount of Z240 is 0.4, then this will be 0.6. We just do a quick check to make sure that mathematically works out. So now we just write this out like a regular average atomic mass problem. So it's a weighted average, so whatever amount of 240 there is times X plus whatever amount of 244 there is times 1 minus X is going to equal our average of 241.38. And then after this just becomes an algebra problem. So 240X plus 244 minus 244X equals 241.38. And then I can just do some rearranging. So I would get negative 4X on this side. I would get 241.38 minus 244, negative 2.62 on this side. And then when I solve for X, I would get 0.655. And then we say this is reasonable because we initially said that there was going to be more 240 anyway. But another thing we can do is check. If this is 0.655, then the other one is going to be 1 minus that, which would be 0.345. And anytime we do a problem where we work backwards, it's always good to check it now working forwards. So does 0.655 times 240 plus 0.345 times 244 equal this number that we established earlier? And check it. There's always some round off error sometimes when we do this, but actually when I do it here, I get the exact answer, so this checks out. So whenever you work backwards, it's always good that once you get your answers to just run it forwards again the normal way that you're used to see if it works. But this is one way to do an advanced type of problem. You can do it with more than two isotopes. You just need to have some connection between these decimal values. So here, it was easy because they have to add up to 1. There's only one relationship. But if there was more than 2, you would have to know some more information. There wouldn't be enough to get every decimal. There'd be multiple ways to answer the problem, so that become a little trickier. But that's pretty much it. So until next time, I am Derek Genova. Have a delightful day.